Hey there. Fellow builders and creators, we live in a three-dimensional world, a world of depth and dimension. Now, we can create and interact with that world in incredible ways thanks to computers. But to unlock this potential, we need to speak the language of three-dimensional space coordinates. Think about building a model or designing a video game level. You don't just place things randomly. You need to know exactly where everything goes, how big it is, and how it's oriented. That's where three-dimensional space and coordinates come in. They give us the framework to precisely define and manipulate objects in a virtual environment. Understanding three-dimensional space is like having a superpower. It allows you to sculpt intricate characters, design breathtaking landscapes, and build immersive worlds that feel real. And the best part, it's not magic, it's just math. So let's dive in and explore the fundamentals of this exciting world. Imagine a room. To describe where something is in that room, we use three dimensions: length, width, and height. In the digital world, we call these dimensions X, Y, and Z. They are the building blocks of three-dimensional space, forming a coordinate system that helps us pinpoint any location. Think of it like a giant grid extending infinitely in all directions. The X-axis runs horizontally, like a line across the floor. The Y-axis runs vertically, like a line from floor to ceiling. And the Z-axis adds depth, coming straight out from the corner where the X and Y axes meet. Each axis has a positive and negative direction indicated by plus and minus signs. So if we move along the positive X-axis, we're going right. Negative X takes us left. Positive Y is up, negative Y is down. And positive Z moves us forward out of the screen towards you, while negative Z goes back into the screen. Now, the XYZ grid we just talked about is called the Cartesian coordinate system. It's the most common one, but it's not the only way to define a point in three-dimensional space. Think of it like speaking different languages. They all convey meaning, just in different ways. Imagine you're trying to pinpoint a location on Earth. You could use latitude, longitude, and altitude. That's similar to how the spherical coordinate system works. It uses two angles, like latitude and longitude, and a distance from the origin, like altitude, to define a point. Then there's the cylindrical coordinate system. Picture a can of soup. You can define any point inside that can using its distance from the center of the base, its angle around the can, and its height. That's the basic idea behind cylindrical coordinates. Each coordinate system has its strengths and is better suited for different applications. Cartesian coordinates are great for general-purpose three-dimensional modeling. Spherical coordinates are perfect for things that involve spheres, like planets or stars. And cylindrical coordinates are useful for things with cylindrical symmetry, like pipes or rockets. So far we've talked about defining points in three-dimensional space, but what about moving objects around? That's where transformations come in. They are the tools we use to manipulate objects in our virtual world. Translation is like picking up an object and moving it to a new location. We simply change its X, Y, and Z coordinates. Want to move that chair across the room? Translation. Rotation is like spinning an object around an axis. Imagine spinning a basketball on your finger. We define rotation using an axis, your finger, and an angle, how much we spin it. Scaling is like changing the size of an object. We can make it bigger or smaller by multiplying its X, Y, and Z coordinates by a scaling factor. Want to enlarge that miniature car model? Scaling's got you covered. These transformations are the building blocks of animation and interaction in the three-dimensional world. By combining them in creative ways, we can bring our digital creations to life. Section 5, the math behind the magic vectors, matrices, and quaternions. Now, you might be thinking, this is all very interesting, but where does the math come in? Well, behind the scenes, computers use powerful mathematical concepts to handle all these 3D calculations. Vectors are like arrows in space. They have both a magnitude or length and a direction. We use vectors to represent things like position, velocity, and forces. Matrices are like grids of numbers that act as powerful tools for transforming vectors. Think of them as magic boxes that can rotate, scale, and translate vectors with ease. Quaternions are a bit more complex, but they're incredibly useful for representing rotations. They help us avoid a nasty problem called gimbal lock that can occur with other rotation methods. Don't worry too much about the nitty-gritty math details for now. Just know that these mathematical heroes are working behind the scenes to make all the 3D magic happen. Okay, we've covered the basics of 3D space and the math behind it. But where is all of this used in the real world? The answer is everywhere. Architects and engineers use CAD, or computer-aided design software, to create 3D models of buildings, bridges, and other structures. These models can be rotated, zoomed in on, and even virtually walked through to get a better understanding of the design. Animators use 3D software to breathe life into characters and creatures for movies, TV shows, and video games. They manipulate virtual skeletons, muscles, and skin using the principles of 3D space and transformations. Game developers use 3D engines to create immersive worlds for players to explore. Everything from the terrain to the characters to the objects you interact with is defined and controlled using 3D coordinates and transformations. And let's not forget about the exciting world of virtual reality and augmented reality. These technologies rely heavily on 3D space to create immersive experiences that blend the digital and physical worlds. Learning about 3D space and coordinates might seem daunting at first, but remember, every expert was once a beginner. The key is to start with the fundamentals and build from there. Think of it like learning a new language. You begin with basic vocabulary and grammar, and gradually you're able to form sentences, paragraphs, and eventually entire stories. As you delve deeper into 3D, you'll discover a world of creative possibilities. You'll be able to model anything you can imagine, animate characters with lifelike movements, and build immersive worlds that captivate your audience. The power to create anything you can envision lies at your fingertips, so embrace the challenge, explore the possibilities, and let your creativity run wild in the exciting realm of 3D. 3D technology is constantly evolving, pushing the boundaries of what's possible. What started with simple wireframe models has evolved into photorealistic graphics, immersive virtual environments, and even tangible 3D printed objects. We're seeing incredible advancements in areas like real-time rendering, which allows us to experience 3D graphics with incredible detail and fluidity. Imagine playing a video game where the environments look and feel as real as the world around you. 3D printing is another game changer, enabling us to bring our digital creations into the physical world. From custom prosthetics to intricate architectural models, the possibilities are endless. As 3D technology continues to advance, who knows what incredible creations the future holds. One thing's for sure, it's an exciting time to be a creator in the world of 3D. Congratulations on taking your first steps into the exciting world of 3D. We've covered the fundamental concepts of 3D space, from the XYZ axes to different coordinate systems and transformations. We've also touched upon the math behind the magic and explored the vast applications of 3D technology. Remember, learning 3D is a journey, not a destination. There's always something new to discover, a new technique to master, or a new challenge to overcome. But with passion, dedication, and a willingness to experiment, you'll be amazed at what you can achieve. So go forth and create, build incredible worlds, breathe life into characters, and push the boundaries of what's possible in the ever-evolving realm of 3D. And who knows, maybe one day you'll be sharing your own 3D creations with the world.